Deep in the infrared shadows of the cosmic dawn, the James Webb Space Telescope may have just brought us closer than ever to seeing the first stars that illuminated the universe. These were not ordinary stars. They were the legendary Population 3 stars, the first generation of stars to emerge from the almost completely pristine hydrogen and helium left behind by the Big Bang. And according to data released in August 2026, astronomers have identified promising candidates that could finally reveal what these primordial giants looked like. For decades, scientists knew these stars had to exist. But actually finding them was another story. The early universe was an almost unimaginable place. There were no familiar galaxies filled with generations of stars. No planets. No heavy elements. Just enormous clouds of primordial gas slowly collapsing under gravity. Then, somewhere within that darkness, the first stars switched on. Population 3 stars are believed to have been enormous compared with many stars we see today. Because the early universe contained almost no elements heavier than helium, these stars formed under conditions completely different from those around modern stars. They may have reached hundreds of times the mass of our Sun, burned incredibly hot, and lived extremely short lives. But their deaths may have changed everything. Inside their cores, nuclear fusion began creating heavier elements. When some of these giants eventually exploded as powerful supernovae, they scattered those newly forged elements into surrounding space. Carbon, oxygen, silicon, iron, and many of the other ingredients that eventually became planets, moons, oceans, and life itself. In that sense, the first stars were more than sources of light. They were cosmic factories. The problem was that their light has been traveling toward us for more than 13 billion years. As the universe expanded, that ancient light was stretched into longer infrared wavelengths. This is where James Webb changed the game. Hubble was incredibly powerful, but its observations were optimized primarily for visible and ultraviolet light. Webb was designed to see much farther into the infrared, allowing astronomers to study some of the earliest objects whose light has been dramatically redshifted by cosmic expansion. But there is an even bigger challenge. Scientists don't simply need to see an ancient object. They need to determine whether its light could actually come from a population of primordial, metal-free stars. That's why these August 2026 observations are so important. The candidates are not automatically confirmed Population 3 stars. Astronomers must carefully examine their spectra, chemical signatures, brightness, and surrounding environments to rule out more ordinary explanations. A distant galaxy containing normal, later generation stars can sometimes produce signals that resemble what astronomers expect from primordial stellar populations. So the real mystery isn't simply, did Webb see the first stars? The deeper question is whether Webb has found the fingerprints of stars that existed before the universe had been chemically enriched. If these candidates are confirmed, the implications would be enormous. We would finally have direct observational evidence for a missing chapter in cosmic history, the moment when the universe transitioned from a simple mixture of primordial gas into a chemically enriched cosmos capable of producing galaxies, planets, and eventually life. And there is something almost poetic about it. The atoms inside your body were not created with Earth. Many of them were forged inside ancient stars. But before those later generations of stars existed, there had to be a first generation. The Population 3 stars may have been those pioneers. They lit the darkness. They created the first heavy elements. They transformed their surroundings. And when they died, they left behind the raw materials from which everything familiar could eventually emerge. For decades, they existed only in theoretical models. Now, with Webb staring deeper into the infrared shadows of cosmic dawn, astronomers may finally be catching their ghosts. And if those ghosts are real, we may be looking at the first chapter of the cosmic story that ultimately led to us. But there is an even stranger possibility. What if the first stars did not simply illuminate the universe? What if they fundamentally changed the rules under which the next generation of stars and galaxies could form? Population 3 stars were born from gas that was almost completely untouched by previous generations of stellar evolution. That means their environment was radically different from the universe we see today. There were no familiar clouds of carbon-rich dust. No abundance of oxygen. No iron. No complex chemistry. Just hydrogen and helium, left behind after the Big Bang. And that created a cosmic paradox. Without heavy elements, the gas could not cool as efficiently as the material forming stars today. That may have allowed enormous clouds of primordial gas to collapse into exceptionally massive stars. Some models suggest these stars could have been hundreds of times more massive than our Sun. Imagine an object hundreds of times more massive than the Sun, burning at temperatures far beyond those of ordinary stars, existing when the universe itself was less than 1 billion years old. But their incredible size came with a price. They probably lived incredibly short lives. Instead of surviving for billions of years like smaller stars, some population 3 stars may have existed for only a few million years before exhausting their fuel. Then came the explosion. And this is where their story becomes critical. When these first stars died, they could have released enormous quantities of newly created heavy elements into the surrounding gas. For the first time, the universe became chemically enriched. The cosmic ingredients were changing. Gas clouds that were once almost entirely hydrogen and helium could now contain carbon, oxygen, silicon, iron, and other elements. Those materials dramatically changed how gas could cool and collapse. And that may have opened the door for smaller, longer-lived stars. Generation after generation followed. The universe went from darkness to the first stars, from the first stars to chemically enriched galaxies, and eventually toward planetary systems like our own. So when Webb searches for population 3 stars, it isn't simply looking for ancient points of light. It's searching for the moment when the universe began becoming chemically complex. But there's another problem. The first stars may not have existed alone. They probably formed inside enormous primordial structures that later evolved into galaxies. That means their individual light could be incredibly difficult to separate from everything around them. A distant galaxy could contain thousands or millions of ordinary stars, while a tiny population of primordial stars produces only a subtle signature buried inside the combined light. This is why astronomers rely so heavily on spectroscopy. Instead of simply asking how bright an object is, they examine its light wavelength by wavelength. Different elements and physical processes leave characteristic fingerprints in that light. And if astronomers find the combination expected from an extremely metal-poor, massive stellar population, the case becomes much stronger. This is also why the August 2026 data release is potentially significant. The observations don't instantly rewrite astronomy. Science doesn't work that way. A promising candidate must survive repeated observations, independent analysis, and careful comparison with alternative explanations. But every new candidate narrows the mystery. And Webb has given astronomers something previous generations never had: the ability to investigate the infrared universe at extraordinary sensitivity and resolution. That matters because the light from these ancient objects has been stretched across billions of years of cosmic expansion. A wavelength that began as visible or ultraviolet light could arrive at Webb as infrared radiation. In a very real sense, Webb is not simply looking farther away. It is looking further back in time. And somewhere in that ancient light may be the evidence of stars that existed before the universe had produced the chemical ingredients necessary for planets like Earth. There is also a possibility that the first stars were far more diverse than scientists once imagined. Some may have been extremely massive. Others may have formed in smaller groups. Some could have collapsed directly into black holes. Others may have ended in extraordinary explosions that scattered their elements across enormous regions of space. Their exact behavior remains one of the biggest unanswered questions in early universe astronomy. Because we have never observed an unquestionably confirmed population 3 star directly. Not yet. That single word matters. Not yet. The candidates Webb is revealing could eventually become the pieces needed to solve the puzzle. And if astronomers finally confirm the unmistakable chemical signature of population 3 stars, we would be witnessing something extraordinary. Not merely the discovery of an ancient star. We would be observing the beginning of cosmic chemistry. The first moment when the universe started manufacturing the ingredients that would later become worlds.